Now we're going to practice our first rule with exponents, and it's going to be multiplying the powers. To multiply powers with the same base, keep the base and add the exponent. Pause the video while you write this down. An example of this would look like 4 to the second power, or 4 squared, times 4 to the third. We keep the base of 4, and we add the two exponents, 2 plus 3, which gives us 4 to the 5th power. In algebra, it would look like this. Any base to an exponent times that same base to an exponent, we keep the base and add the exponent. On the left-hand side of your notebook, try these two examples. 6 squared times 6 to the 4th. Also, negative 1/2 to the third times negative 1/2 to the 6th. Remember the rule, keep the base and add the exponent. Pause the video and try these two examples on the left-hand side. For the first example, 6 to the second power times 6 to the 4th power, the base is 6, so we keep the base, and we add the exponent. 2 plus 4 is 6. Did you find the value of 6 to the 6th power? 6 expanded times itself 6 times. Big number. 4, 6. If you got this far, that's fantastic. That's really what I was looking for. If you took it one step further, that's what you would say. Negative 1/2 to the third power times negative 1/2 to the 6th power. I keep the base the same, which in this situation is negative 1/2, and I add my exponent. 3 plus 6 is 9. Negative 1/2 to the 9th power. Another rule that we need to consider when we're working with multiplication of powers is to find the power of a power. What you want to do is keep the base the same and multiply the exponent. For example, 3 to the 4th power to the 3rd power would be 3 to the 12th power. You can see that this power is being multiplied by a power. That's why it's called power of a power. The base is 3, so I keep that base the same, and I multiply the exponent. 4 times 3 is 12. The algebra for that would be w to the 5th power to the 4th power. The base is w, so we multiply the two exponents, which gives us w to the 20th power. On the left-hand side of your notebook, I want you to multiply 4 to the 4th power to the 3rd power, and y to the 2nd power to the 4th power. Pause this video and try these two examples on the left-hand side of your notebook. For the first example, the base is 4, so it stays 4, and we multiply the two exponents. 4 times 3 is 12. In the second example, y to the 2nd power, the base is y, and we multiply our two exponents. 2 times 4 is 8. The third and final rule that we need to remember when multiplying powers is to find the power of a product. We distribute the power to each factor. So for example, 2x to the third power. This 3 gets distributed to each term inside the parentheses. So 2 to the third power times x to the third power. 2 to the third power we can simplify to 8, and x to the third power stays as x to the third power. Now notice that I have it separated by a multiplication point here, and I took it out here. We don't have to have a symbol when we're multiplying. Remember that. If you had 8 times x, it would be the same thing as 8x. Another example, 3xy to the second power. I'm going to take this exponent and I'm going to distribute it to each term. So I have 3 to the second power times x to the second power times y to the second power. Each of these terms gets that power. I can simplify this. 3 to the second power is 9. X to the second power remains x to the second power. There's no simplifying, we don't know what x is. And y to the second power stays as y to the second power. The last piece of simplification that I did was I just took out those exclamation points. These two terms are exactly the same. This is just the clean version of writing it without the dots, the multiplication in between each term. Okay, on the left-hand side, I didn't have any examples written down for this one. Hold on one second. Let's try this one. 3mn, so 3 times m times n, all to the second power. So this is called the product, the power of a product, because product means multiplication, and you can see that I have 3 terms being multiplied raised to a power. That's why we call it power of a product. So on the left-hand side, let's expand this power of a product. Now remember, 3, m, and n all get that power. So we have 3 to the second power times m to the second power times n to the second power. I can simplify that further because I know that 3 to the second power is 9. M to the second power is just m to the second power, n to the second power. And the last step for simplifying is just to remove those multiplication symbols. 9m squared, n squared. That would be your final answer. Go ahead and try this one on your own on the left-hand side. 0.5 x y to the 4th power. Pause the video while you do this problem on your own. You're supposed to be pausing the video and doing the problem. Haha. Alright. Each one of these will get that power of the 4th. So 0.5 to the 4th power times x to the 4th power times y to the 4th power. I can simplify this just a little bit. 0.5, I actually should do this one on my calculator, times 0.5 times 0.5 times 0.5, 4 times is 0.0625. X to the 4th is x to the 4th, y to the 4th. And then the last step is to remove those multiplication symbols. Now that we've completed this set of rules for multiplying powers, I want you to use your notes to help you go through practice examples on page 210 in your workbook. Page 210 in your workbook. You'll be simplifying expressions using all three of these rules, multiplying powers with the same base, power to a power, power of a product. Refer to your notes as needed. Any spot where there's any kind of expanding your notation, I want to see that. I should not just see an answer written down for any of these examples on page 210 in your workbook. I should see your work shown. I will be looking for that tomorrow.